A warm welcome to everyone. I hope my audio is clear to you. Welcome back again. Today is the last lecture of the interior of the earth, that is part 3. I hope you have liked the first two videos of this series, that is part 1 and part 2, where we have revealed a lot of uh, that questions that we have, a lot of doubts, a lot of tricky puzzles that we have solved. That why the earthquake is going on, what are the characteristics of waves, how in India and in world the seismic activity goes on, what is inside the earth, what is the physics and chemistry behind it, and finally we have interpreted everything like a geographer. In this last lecture, today we will understand the concept of the structure of the earth and volcanoes, types and landform. Particularly those who study volcanoes and types and landforms, those peoples are known as volcanologists. Those peoples are known as volcanologists. Volcanology is not a integral part of geography, by the way, because to study volcanology you need a good command in chemistry. You should have a very good command in chemistry. But in geography, volcanology, particularly we used to study volcanic activities in the surface area, that is the landforms formed by lava. There are two distinctive difference between lava and magma. You already know this. So particularly geographers used to focus on the characteristics, distribution, type and occurrence of lava in the surface. So myself Pratik Chakraborty, today's topic is about interior of the earth part 3. Let's begin our journey to the inside of the earth. When you're talking about the structure of the earth, our earth composed of three distinctive layers. First layer, the topmost layer, is known as the crust. Okay, but above crust there is another layer, you already know, that is known as lithosphere. Litho means what? Soil or surface. Litho means what? Soil or surface. So the crust is one of the important layer, and it is the outermost solid part of the earth. It is brittle in nature, that is, it is very much fragile in nature. It breaks down easily. The thickness of the crust varies under the oceanic and continental areas. Suppose in oceanic plates, the thickness of the crust will vary, and in the continental plate, that is in the mountain area, in plateau area, this kind of places, the crust will vary. The thickness of the crust will vary. Oceanic crust is thinner as compared to continental crust. The crust of ocean is comparatively thinner than continental crust. The mean thickness of oceanic crust is 5 km, whereas the thickness of continental crust is 30 km thickness. Okay, the continental crust is thicker in areas of major mountain system. It is as much as 70 km thick in Himalayan region, and it is made up of heavier rocks having density of 3 gram cubic centimeter. Okay, so this is the characteristics of continental crust, and this type of rock found in oceanic crust is basalt. The mean density of material in oceanic crust is 2.5 gram cubic centimeter. So particularly whenever you used to say that the density, why this density is varying, why in ocean it is thick, it very comparatively it is only 5 kilometer, and in continent it is 30 kilometer, because the reason is that when our continent and ocean, there is a gradual subduction or gradual slope you can see towards ocean. So that's why the oceanic plates is comparatively thicker, 5 kilometer, 10 kilometer approximately. But continents are much, upward. It's much upward than the ocean. That's why the continents are not submerging inside the water. That's the reason. So this is a basic difference between the oceanic crust and continental crust. Particularly, crust plays a very important role because our entire surface and subsurface feature has been dealt in crust. Okay, the lithosphere was there, and it is one of the most important part. Next, we are moving to the concept of mantle. You can see here, you can see it is just 1 minute. I'm pointing out for you. Here you can see the concept of mantle. Okay, so mantle, why it is important? The portion of the interior beyond the crust is called mantle. The mantle extends from Moho discontinuity to a depth of 2,900 kilometer. Okay, so beneath crust, after after crust, we having this layer, that is the mantle layer. Okay, this layer is very important. The upper portion of the mantle is known as asthenosphere. You can see written here asthenosphere in this diagram. Okay, the upper portion of the mantle is known as asthenosphere. The word astheno means what? Weak. The word astheno means what? Weak. It is considered to be extended up to 400 kilometer. It is considered to be extended up to 400 kilometer. It is the main source of magma that finds its way to surface during volcanic eruption. A question may come that from which layer the magma comes out, or formation or circulation of magma takes place, that is in asthenosphere. It is the main source of magma. Okay, its way to surface during volcanic eruption. It has a density of higher than 3.4. The density of asthenosphere is approximately higher than 3.4. The crust and the uppermost part of the mantle are called lithosphere. Okay, the crust and the uppermost and mantle is called the lithosphere. So above asthenosphere we having lithosphere. Its thickness ranges from 10 to 200 kilometer. Its thickness ranges from 10 to 200 kilometer. The lower mantle extend beyond the asthenosphere and it is in solid state. So this part is the lower mantle. Okay, the crust and the uppermost part of the mantle is called lithosphere. We have understood its thickness is about 10 to 200 kilometer, and the lower mantle beyond the asthenosphere is solid in nature. So this part, this yellow marked part, is comparatively solid. So this part is solid, this part is semi-solid or liquid, particularly not probably liquid, we used to say semi-solid in nature. Okay, so this kind of gradual differentiation you can see inside the earth crust. The last and the most important part is the core. As indicated earlier, the earthquake waves velocity helped in understanding the existence of core of the earth. The core mantle boundary is located at the depth of 2,900 kilometer. This is the core mantle boundary, 2,900 kilometer. The outer core is in liquid state, whereas in the inner core is in solid state. You can understand this thing. The outer core is in liquid state and the inner core is in solid state. So let's define one thing. This is solid. You can see the inner core is solid. After that we have a liquid core. Again we have a solid mantle. Again we have a liquid mantle. This is the differentiation. Okay, solid, liquid and solid liquid. When rotation used to take place in earth, these liquid and solid, these reactions, okay, these heat, differentiation of heat, generate electricity, okay, electric field, and this electric field energize the solid particle to behave like a magnet, hence the concept of electromagnetism in our planet. I hope this concept is clear to you. The density of the material at the mantle core boundary is 5. There is the density of the material is 5 gram per cubic centimeter, and at the center of the earth it is approximately at 6,300 kilometer. That is roughly 5 this in this part 6,300 kilometer. The density value is around 13 gram cubic centimeter. The core is made of a very heavy material, mostly constitute of nickel and iron, and this layer is also known as NIFE, N-I-F-E. So that is the basic stratification of the earth's interior. I hope till this much is clear. Hence one thing you can conclude from here, that our continental plates is floating on the semi-solid substances, that is in asthenosphere. In a next chapter we will decode this thing, that how this vast landmass like a ship floating in this semi-solid structure. This is a very important question. I hope this part is clear to you. This is a 3D explanation of whatever we have studied till now. This part you can see, this is a lithosphere in simple language. This is a lithosphere. This part consists of you can say that crust mantle kind of thing. This part is lower mantle and upper core, and finally this part is the solid core. This is the 3D description of the diagram. On the other hand, you can see here asthenosphere, rigid mantle, outer core, inner core. Like this way the diagram has been shown. So finally we have a interpretation that how the structure of the earth looks like. Next important question is that we are unable till now, we cannot go inside this part, hence a lot of things are there which is based on assumption. Maybe this chemical is present there, maybe this kind of heat sustain there. So whatever we used to do, it's based on our assumption and by seeing the landforms that is in front of our eyes, because no other technology still now is available to go inside this chamber. I hope the structure of the earth is clear to you. Next, moving on to the next important part, that is volcanoes and volcanic landforms. So you can easily understood the concept now that why volcano is important to know. If you study geography, earth science, volcanoes are very important. Volcanic landforms and volcano, particularly those who are studying geology, though for them volcanoes are important, volcanological concepts are important. Those who are studying geography, volcanic landforms are important. Why these things are important? Let's discuss. You may have seen photographs or pictures of volcanoes on a number of occasions. A volcano is a place where gaseous ashes and or molten rock material lava escape to the ground. The layer below the solid crust is mantle. The layer below the solid crust is mantle. It has higher density than that of crust. The mantle contains a weaker zone called asthenosphere. It is formed that the molten rock material find their way to the surface. That means whatever the magma coming out in form of lava in the landform, all these things comes from asthenosphere. Okay, the material in the upper mantle portion is called magma. Once it starts moving towards crust or it reaches the surface, it is referred to as lava. So I think now you have a clear-cut idea what is the difference between magma and lava. The material that reaches the ground includes lava flow, pyroclastic debris, volcanic bombs, ash, dust, gas, and nitrogenous compound, sulfur compound, minor hydrogen and argon compound. Mostly, volcanic eruption emits harmful gases. This thing you have to understood. Many a times it has been seen that due to volcanic eruption, a series of volcanic eruption can cause a rise of global temperature by 1 degree or 2 degrees C. This thing is there. Okay. Today we will understand the concept of just a minute. Okay. Today we will understand the concept of that how these volcanic mountains formed, what are the characteristics and shaping of these volcanic mountains. This thing we will study in our next part. Moving on to the next part, we can see here. From here we can easily show presentation. Just a minute. Okay, so types of volcanoes. When you're talking about the types of volcanoes, first volcano that is the shield volcano. What is a shield? Shield means what? For example, many a times you've seen shield. Shield particularly, you can say that it's a hard constructive protective layer from all the side. That is a shield. Maybe in many war movies you have seen the soldiers carrying a sword and a shield. Shield particularly protect the soldier from the incoming forces. Okay, so what is a shield volcano and how it is formed? Let's see here in this video. It is not working. Okay, so what is shield? Just we can understand from it here. Particularly shield volcano, when huge amount of lava or basalt started flow continuously. Okay, started flow continuously, construct shield. How shield is formed? You can see here in this video. Okay, volcanic eruption taking place, and it is spreading. See, continuous spreading, and it is making it more larger. Again it is spreading. So that means what? A series, a continuous deposition of lava for a longer period of time, making parallel and symmetrical development of layers. That is known as shield volcano. This kind of volcanic eruption you can see in Hawaiian Island. Below you can see an example of shield volcano. Okay, when magma comes, when the lava flows, it again construct the mountain. Again lava flows, it construct the mountain. Hence, a shield volcano, in shield volcano particularly, you will say that the mountain will gradually rise for a period of time. These volcanoes are mostly made up of basalt, a type of lava that is very fluid when erupted. For this reason, these volcanoes are not step. So in this sequence, you cannot see steps. Okay, they become explosive if somehow water gets into the vent. Otherwise, they are characterized by low explosivity. If water added in this this reaction, then it will be very much violent. Otherwise, it is low. Explosivity is very much low in this. The upcoming lava moves in form of a fountain and throws out the cone at the top, and a vent develops into cinder cone. Cinder cone means what? A cone with a large depression. That is a cinder cone. So these volcanoes are also known as cinder cone volcanoes. Next, we having the concept of composite volcano. In composite volcano, two things you can see. First is that layer. Easily you can demarcate different layers in composite volcano. These volcanoes are characterized by eruption of cooler and more viscous lava. Eruption of cooler and more viscous lava. This kind of volcano doesn't, these volcanoes often result in explosive eruption. Although, along with lava, large quantities of pyroclastic material and ashes find their way to the ground. Pyroclastic means what? Very thick, very dense material. It comes from this volcanic eruption. So let's see how this composite volcano forms. See, a gradual eruption, smoke and dust, it will compose. Again, a gradual eruption, smoke with dust, it will compose a layer. Again, gradual eruption with smoke and dust, it will make a layer. Like this way, it will cease for some time, and pyroclastic interlayering you can see in this kind of volcanic mountain. But in shield volcano, you cannot say different layers are there. You cannot see. But here, a deposit of ash, a deposit of lava, a deposit of ash, again a deposit of lava. Like this way, composite volcano forms. The material accumulates in the vicinity of this vent opening, leading to the formation of layers, and this makes the amount appear as composite volcano. Okay, a huge amount of composition you can see of different materials in this mountain structure. So shield volcano and composite volcano, I think it is clear to you. Next, we are moving to the concept of caldera. What is a caldera? Below you can see an image of a caldera. It is a kind of lake, beautiful lake it is showing. These are most explosive of the Earth's volcano. They are usually so explosive that, let's see the video here. They're usually so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. So in this sequence, what happened in a volcanic mountain, certain small amount of volcanic eruption takes place, and this volcanic eruption weakens the mountain from each and every part. Hence, due to sudden volcanic eruption for a repetitive time, it weakens the mountain, and after a long time, all the material collapse and a depression takes place. The collapsed depressions are called caldera. So after a long time, when all the magma dies, the activity extremely completes and all, these collapse structure, okay, it behaves like a lake. When rainfall used to take place, it holds water. That's all about caldera. Okay, their explosiveness indicates that the magma chamber supplying lava is not only huge but is also in close vicinity. That means if you go deeper inside the that water body, if you go inside the lake, if you dug some holes and if you try to go inside, its possibilities is there that you can discover a magma chamber. Okay, so that is caldera. So from this part, one thing it is very clear: volcanic eruption is based on 2-3 types: active volcano, dormant volcano, and extinct volcano. This concept you have already learned in class 9-10 geography. Active volcano, every year volcanic eruption will take place. Dormant means what? Maybe 5-6 years it has a probability to again erupt. And extinct means once there is no chances of eruption. Okay, so on the basis of activity we can divide volcanic eruptions. Next part we are having the flood basalt province and mid-oceanic ridge. See, flood basalt means when eruption takes place in volcanic. When you will do graduation in geography or geology, there is a different types of eruption mechanism in volcanology. You will study. So, flood is a kind of a eruption in volcano. You have seen water flood, river water flood. What happens? A sudden amount of water comes and it devastates the entire area. These things also happens in with lava, also in volcanic activity also. These volcanoes outpour highly fluid lava that flow for a longer distance. So in a very symmetrical, in a very active way, this lava flows for a longer distance. Some parts of the world are covered by 1,000 square kilometers of thick basalt lava flows. There can be a series of flows with some flows attaining thickness of more than 50 meters. Individual flow may extend for hundreds of kilometers. The Deccan Trap from India, presently covering the most of Maharashtra plateau, are a much larger flood basalt province. It is believed that initially the trap formation covered a much larger area than the present. So the Deccan Plateau, we used to say, present India, it is one of the oldest landmass of the world. One of the oldest landmass. I am saying the Deccan Plateau, the peninsula India, having the Deccan traps. Next point is the mid-ocean ridge volcano. These volcanoes occur in a volcanic oceanic areas. There is a system of mid-ocean ridges, more than 70,000 kilometer long stretch through all the ocean basins. The central portion of the ridge experience frequent eruption. We shall be discussing it in the detail in next chapter. But for in this chapter, one thing I like to share you that the Pacific Ring of Fire. You have heard this term, the Pacific Ring of Fire. What is this Pacific Ring? The reason is that I am sharing this video because it has a very good connection with this thing. In this video you can see this is the Pacific Ocean and I have drawn a ring here. This is the Pacific Ring of Fire. This place consists of 95% of the active volcano region of the earth. 90% of active volcano regions of the earth. Okay, this region, this entire region. So why it is important? Pacific Ring of Fire, this is the zone of active volcano. This place is also known as mid-oceanic ridge. Mid-oceanic means what? See, this map is in the mid of the ocean. This map you can see is in the mid of the ocean. Mid-oceanic ridge means what? Boundary of the landforms. Okay, so that is Pacific Ring of Fire. Why this layer is important? This layer is important because in Pacific Ocean, numerous volcanic eruptions takes place. Numerous volcanic eruption through a series of time takes place. So we will discuss this concept in next chapter. Lastly, we are in the last part of this chapter, that is the volcanic landforms, intrusive and extrusive. This is the last part of this unit. So we have understood about the formation of volcanoes, types of volcanic mountains. These things are there, the different process of volcanic activity. Today we will understand now the concept of volcanic landforms. Intrusive means what? Inside the surface landforms used to take place, intrusive forms. So see, igneous rocks are classified as volcanic rocks. Volcanic rocks are the rocks that formed due to when they comes out in the surface and cools. That is volcanic rock. Plutonic rocks are the cooling in the crust. That means they don't come out this kind of lava, they don't flow in the surface, they cools in beneath the surface of the earth in the crust. That is plutonic rock. Okay, so based on this concept, volcanic landforms, there are four important types of landforms. One is known as the batholith. Batholiths are gigantic bodies. Okay, batholiths are gigantic bodies, large body of magmatic material that cools in the deeper depth of the crust. Okay, develops in form of large domes. They cover large areas and at times assume depth that may be of several kilometers. So these are dome-like structure. I will show you in animation. They are gigantic bodies. Batholiths are the cooled portion of magma chambers. After batholith, we are having laccolith. Laccoliths are large dome shaped, okay, large dome shaped intrusive bodies, pipe like. It resembles pipe like, okay, structure. It resembles the surface volcanic domes of composite volcano. Only these are located at deeper depths. The Karnataka plateau is spotted with dome hills of granitic rocks. So if you go to Karnataka, the Karnataka plateau, beneath Karnataka plateau you can see laccolith structure, you can see. So let's understand through diagram batholiths and laccolith. Here you can see a diagram. Batholith you can see, okay, and laccolith also you can see in this diagram. So there is batholith in this diagram, you can see here, and there is laccolith, okay. So laccolith used to comes when the batholith makes a way in a pipe like structure, and when they store, when they submerged here, it is a laccolith. In this way the laccolith structure forms. So in animation, let's see how it looks like, laccolith and batholith. Okay, this is a rock strata, and beneath there is a magma chamber. What is happening in this magma chamber? Magma chamber usually making intrusive structure. See, so this part, if I say that, uh, just a minute. Okay, batholith you can see here. Okay, this is the larger dome-like structure, and laccolith, from this diagram you can easily visible in this diagram the concept of laccolith. Okay, so laccolith and batholith. After these things we have lapolith, phacolith and silts. Lapolith particularly, it is a saucer shape concave to the sky body. It is called lapolith. Okay, a wavy mass of intrusive rock are called phacolith, and seal are horizontal body of intrusive igneous rock. So let's see in the diagram. Okay, first is the saucer shaped. So lapolith is, you can see it is visible here. Seal is there, you can see seal here. Okay, seal you can see here, and laccolith is there, but lapolith is not there. Lapolith is very much unusual, you cannot see lapolith very much. Okay, lapolith and phacolith, it's very much difficult to to spot out, but seal you can easily see here, that a horizontal structure it is making. Okay, in this diagram you can see a horizontal structure it is making, that is a seal, okay, in this diagram. And lastly, we're having the concept of dikes. When the lava makes its way through cracks and fissures developed in the land, it solidifies almost perpendicular to the ground. It gets cooled in the same position to develop wall-like structure. That is a dike. A dike particularly is a wicket. Cricket, you have seen, in cricket wickets are used. So dikes are example of wickets. Okay, this is an example of wicket, dikes. Okay, so seal are horizontal distribution of magma, batholith are dome shaped, and laccoliths are umbrella shaped. Particularly a pipe like structure you can see, and beneath, above the pipe like structure you can see a saucer shaped, a dome shaped in laccolith. So this is the intrusive landforms that we have. So that's all about the today's lecture, that we have understood the structure of the earth, the different process we have seen, different types of volcanoes, shield volcano, composite volcano, after that the structure of the earth, the diagrams we have seen, and finally the intrusive landforms. So with this, our interior of the earth chapter completed. There is a small homework for you, you should try, that is, write a short essay on Deccan Trap, its formation. So you can take reference from Google, you can take reference from National Geography, which is a website, it's a very good website. You can get all the information about Deccan Trap and try to make a good note with diagram, okay, and submit the note after offline, during the time of our offline classes. So that's the end of this chapter. Thank you everyone, and I hope you have liked this series of interior of the earth. Next class we will discuss about the distribution of oceans and continents, that how the continents emerged, this kind of theories are there, we will understand this chapter. Okay, thank you very much, take care everyone.